In this video, we're going to talk about what stoichiometry is and how to solve stoichiometry problems.
A lot of people will be scared here. A lot of people will be scared, and I'll name them.
Stoichiometry sounds like a very complex word, but actually, the first thing that you should ask here is how much. Stoichiometry comes from two Greek words, stoichion meaning element and metron meaning measure. Stoichiometry is a way of scientists to measure elements and other chemicals in a chemical reaction. Here we use a balanced equation to calculate amounts of reactants and products. With that being said, you should master balancing chemical equations first before dealing with stoichiometry.
We are going to pretend we didn't hear that.
If you're unfamiliar with balancing of equations, we have videos for that. To make stoichiometry easy, let's have an analogy. Let's say you want to prepare a burger because you're so hungry or you just want to eat burger. To make a burger, you need a bun, cheese, lettuce, and a burger patty. The question is, how much of each ingredient do we need?
None. None.
Okay, to make a burger, we will need one bun, one slice of cheese, two leaves of lettuce, and one burger patty. In chemistry, this is your balanced chemical equation. So it's important to know this. Okay, so let's say you want to prepare three burgers, one for your brother, one for your dad, and one for your sister. So the question will be how much of each ingredient will you need to prepare three burgers? So let's try to solve it. Again, this is the recipe. The first thing that you need to do is to ask,
And so we're not gonna have that, okay?
how many buns do you need to make three burgers? And then we'll start with the given. Since we're making three burgers, write it there, three burgers. And then we have to multiply this, the ratio of bun to burger. That would be one bun and one burger in the bottom. The burger will cancel. So multiplying these two, we will get three buns. So to make three burgers, you need three buns. So let's try this the other ingredient. For cheese, three, and we will need six leaves of lettuce. And lastly, three burger patties. Okay, so this ratio is what we call the molar ratio. And where do we get this?
You heard it?
It's from the recipe. And we have said that the recipe is the balanced equation. So therefore, the balanced equation is the conversion factor. Okay? So to make three burgers, you will need three buns, three slices of cheese, six leaves of lettuce, and three burger patties. So we will try this concept to chemicals in the exact same way. Ready?
She's about to do what she's about to do.
Okay. Consider this synthesis reaction to form ammonia. So this is also called as the Haber process. The Haber process is used in making fertilizers. The first thing that you should do is to check if the reaction is balanced. Okay, you have two nitrogen atoms in the reactant side and you have one nitrogen atom in the product side. So you need to put 2 in front of ammonia, but this will give you 6 atoms of hydrogen. So to make it balanced, you need to put 3 in front of hydrogen. Okay, now the equation is balanced. This means that one nitrogen molecule reacts with 3 hydrogen molecules to form 2 ammonia molecules. So what if we have 5 nitrogen molecules? So these molecules will react with 15 hydrogen molecules to form 10 ammonia molecules. This tells us that regardless the amount, the ratio of nitrogen, hydrogen, and ammonia will still be 1 is to 3 is to 2. So what if we have this number of nitrogen molecules? It looks familiar, right? It is the Avogadro's number. So what if we have this huge number? This number is equal to 1 mole. So it's still the same. 1 mole of nitrogen atom will react with 3 moles of hydrogen atoms to form 2 moles of ammonia. Okay, so let's consider this problem. How many moles of nitrogen do you need to make 18 moles of ammonia? So again, you have to start with a given. So 18 moles of ammonia. Then multiply this to the ratio. Since the given is ammonia, we have to put it in the bottom. Then you just copy the coefficient. Since we're looking for the moles of nitrogen, you have to put it in the top. Then copy the coefficient. So look how the units will cancel. So we now have the moles of nitrogen. Solving for this will give us 9.0 mole of nitrogen. It's 9.0, not 9, since we have two significant figures in the given. Okay? Don't forget that. Next, how many moles of ammonia can you make from 0.513 moles of hydrogen? Same process. Start with the given, multiply to the ratio, copy the units of the given below plus the coefficient, then copy the unit of what is being asked plus the coefficient in the top. Then cancel the same unit. This will give us 0.171 mole of ammonia. That's it for stoichiometry. So you may check out other videos for the mole ratio problems and how to solve stoichiometry problems. Okay, so if you like the content, subscribe, like, comment, and turn on the notification.
I do not want to comment.